Hey guys, welcome back. AP Statistics 2020. They released this question number 2, so I'm going to just give you guys the answers that I came up with. If you want, you can press pause and try all of these problems by yourself and just see if your answers match my answers, okay? So I hope I do a great job explaining this. A park ranger at a large national park wants to estimate the mean diameter of all the aspen trees in the park. The park ranger believes that due to environmental changes, the aspen trees are not growing as large as they were in 1975. Okay. Data collected in 1975 indicate that the distribution of diameter for aspen trees in the park was approximately normal, with the mean 8 inches and a standard deviation of 2.5 inches. Now, because they gave you the mean and the standard deviation together in one shot deal, you get two things out of this, especially that it says approximately normal. You know it's a z-score, and you know that the standard deviation is sigma and not s, okay? They didn't take a sample. So that's a z-score. That should automatically tell you you're going to do a z-score. It says find the approximate probability that a single randomly selected aspen tree would have a diameter less than 5.5 inches. So I did that right here in part A. Mu equals 8, sigma equals 2.5, and they want to know the probability that a single, that's why I put x and not x bar, a single tree is less than 5.5 inches in diameter. So z is equal to x minus mu over sigma. Z equals 5.5 minus 8 over 2.5. Z equals -1. And the probability of obtaining a test statistic of -1 or less is 0.1587. Okay? You guys can press stat, go over to test, and do Z test, and that would give you the answer, or you can use a formula sheet. Okay? I highly recommend that you guys print out a formula sheet before the exam. Great. Let's move along. The park ranger selects a random sample of 30 aspen trees from the park in 2020 and measures their diameters. A dot plot in the diameter is shown below. Now, I put these numbers here. That's 1 dot, that's 3 dots, that's 4 dots, and so on, okay? And the reason why I did that is for a specific reason right here. Describe the distribution of the aspen tree diameter from the sample. So what I wanted to do is anytime you guys are describing the distribution, you need the center, shape, and spread. The center in this case is going to be my median. There are 30 trees, okay? To find the median, you take n plus 1 divided by 2. So it's 30 plus 1 divided by 2. So it's about the 15th and a half number. So I just counted. I go 1 and 3 makes 4. 4 and 4 makes 8. 8 and 6 is 14. Pardon me. Yeah, 14. Okay. Whoa. And then I found the 15th and 16th guy right there. Okay. So that guy is going to be about 5.7. You would never write it like this. You would write in complete sentence in context. Okay. Aspen tree. The median aspen tree aspen tree diameter is 5.75 inches. We notice that the shape of the distribution is bimodal because there's two peaks, one at 5.25 and the other one at 9.25. Okay, so let's get a different highlighter. That's there, and that is there. Thank you. Now we're going to say the range is pretty large. It ranges from 10.25 to 3.75 to 10.25, so it's about 6. And don't ever forget gaps and clusters with a gap between 6.75 and 8.25 diameter, okay? Or inches, rather. So that's how you describe the distribution, but you never ever write it like this in bullets. You write it in complete sentences. Great. Now, if you ever saw my last video on the other example that I actually made up without actually even seeing this, so that's interesting that we think the same. I said the park ranger uses the sample data to construct a 95% confidence interval for the mean diameter of all aspens in the park in 2020 as 5.6 to 7 inches. Calculate the point estimate and the margin of error. That's easy. We know that it's between 5.6 and 7.0 is the 95% confidence. The point estimate is X bar, okay? 5.6 plus 7.0 divided by 2 is how you get the point estimate. You just have to average the confidence interval. The error is how far away the midpoint or the point estimate, X bar, is to any of the ends. So you can find it by either saying 7 minus 6.3 or 6.3 minus 5.6. Nevertheless, you can rewrite this as 6.3 plus or minus 0.7. Okay, so that's how we find the point estimate, X bar. A point estimate can also be p hat, but we're not talking about proportions, okay? And the margin of error is the distance from the middle to the either end. Finally, letter D says, based on the confidence interval, does the park ranger have convincing evidence that the mean diameter for all aspen trees in the park is different than 8 inches, as it was in 1975? Now, obviously, we have to base it on the confidence interval. This was my confidence interval. So 5.6 to 7.0. I put it right here, okay? And this is my 95% confidence interval. Now, where does 8 fall? Well, 8 doesn't fall in the interval, it falls in my rejection region, okay? So first and foremost, you should write out HO, mu is equal to 8. HA, mu does not equal to 8. Do I have to? Absolutely. Now, the confidence interval, you'll say that 8 falls outside of the confidence interval, so I wrote it here in green, okay? Since 8 does not fall in the confidence interval, we have evidence to suggest it's different. At alpha equals 0.05, you should, and I think you must include alpha equals 0.05. How do I know that? It's 0.05 because when it's a two-sided test, when it says different, you got to take this and this. Had it been a one-sided test, then you would have said at alpha equals 0.025, okay? Finally, there was a part E. It said aspen trees tend to be smaller in the highlands of the park because they are subject to strong winds. While the number of aspen trees in the highlands of the park is about the same as the number of aspen trees in the lowland of the park ranger is concerned that 24 out of 30 trees in the random sample came from the highlands. Propose a sampling method to address the concern. So they told you, hey, both in the highland and the lowland of the park, they have the same number. So I'm getting such a difference in proportion. So what can I do? You could block by highland and lowland, okay? Randomly choose 15 trees from each. That way you can guarantee to have the same proportion from each. So propose a sampling method to address the concern and describe the benefit of using the sample. So the sample is to block by these lands, highland and lowland, and the benefit is that you will be able to get 15 of each, and then you can really discuss the actual diameter of the aspen tree. I hope everybody's well. Stay happy, stay healthy. Good luck on your exam.